So today's lesson is going to be a combined lesson. So lesson 94, solving multi-step absolute value equations, where we're going to isolate absolute value equations and write solutions using set notation. And then lesson 101, solving multi-step absolute value inequalities. Again, isolate absolute value inequality, rewrite using and uh, or inequalities, and write solutions using inequality notation. Combine these because they are very similar. So for the notes, remember we want to isolate absolute value using inverse operations. Then we rewrite as two equations where you have one positive, one negative value, and then solve for a variable using inverse operations. So here's our examples. So first example, we have absolute value of x divided by 5 plus 3 is equal to 18. So the first thing that we want to do is subtract 3 from both sides. That gives us the absolute value of x divided by 5, which is equal to 15. And then multiply both sides by 5. And we get the absolute value of x is equal to 75. And then remember that x equals negative 75, or x can equal positive 75. So for this one, solution set is negative 75, 75. And that's how we would write it as set notation. For 4, this time we just add 9 to both sides. 9 minus 9 cancels out, leaving us with 4 times the absolute value of x equals 24. Divide both sides by 4. 4's cancel out. We have the absolute value of x equals 6. And then we know that x equals negative 6 or x equals positive 6. So our solution set is going to be negative 6 comma 6. I'm going to move all that side up a little bit just so it's about the way. So another example, we have 5 over 2 times, or 5 times the absolute value of x divided by 2 plus 4 equals 4. So we subtract 4 from both sides. 4's cancel out, and we have 5 divided by 2 times the absolute value of x equals 0. Well, in this case, we know that multiplying both sides by 2 over 5 to cancel out. So multiply by 2 over 5, and we're left with the absolute value of x equals 0, and so x equals 0. Since there's not two numbers, normally I would just leave it as x equals 0. I wouldn't worry about writing it out using set notation. Here we have 2 times absolute value of x divided by 6 plus 3 equals negative 1. So now we subtract 3 from both sides, cancels out, and we have 2 times the absolute value of x divided by 6 equals negative 2. Here we can go ahead and multiply by 6 over 2 on both sides. So 6's cancel out, 2's cancel out. Here we get the 2's to cancel out, and we have the absolute value of x equals negative 6. So this is not possible, so there is no solution. It's the empty set. Or you can write no solution. And then there's 2 more examples. This time, instead of having the multiplying 2 by an absolute value, we've got 2 inside of the absolute value. So it's still going to be the same process. subtracting 9 from both sides in order to isolate the absolute value. Leaves us with absolute value of 2x equals 6. We write it twice, so we have negative 6 equals 2x, or 2x equals positive 6. And now we just solve that twice. So we divide both sides by 2 on both parts. And we get negative 3 equals x, or x equals positive 3. And so the solution set here is negative 3, 3. This time we've got a few more parts. We've got 6 times the absolute value of x plus 3 minus 8 equals 10. So going to first add 8 to all parts. We're isolating the absolute value. So we have 6 times the absolute value of x plus 3, and that equals 18. Now we can divide by 6, and that leaves us with the absolute value of x plus 3 equals 3. So we have negative 3 equals x plus 3, or x plus 3 equals positive 3. Subtract 3 from all parts. And that leaves us with negative 6 equals x, or x equals 0. And so now our solution set here is negative 6, comma 0. So this is actually the first example that we've had so far where our solution set was not the same number twice, like negative 3 and 3. So be careful of that. Don't automatically assume it's going to be negative 6 and 6. So now going to have the lesson 101. It's the same process. You're still isolating the absolute value using inverse operations, but now we'll have to apply a rule. So if we have the absolute value of k is less than a, we can rewrite that as an and statement. So this is an and statement. And so we have negative a is less than k less than a. You will see this a lot as note taking for notation when you're doing other things. Instead of us having to say if a is between 0 and 1 and negative 0 and negative 1, we'll just say the absolute value of a is less, or absolute value of k is less than a. So it's just a shorthand way of doing some notes in the future as well. Then we have the absolute value of k is greater than a. So that tells us that k is either less than negative a or k is greater than a. So, remember the and statement is going to be between, and the or statement is going to be away. So, and it works whether it's strictly less than, or if it's less than or equal to, greater than, or greater than or equal to. So that still is the same. And then you just solve for variables using inverse operations like we do with our compound inequalities. So I would just say like with our compound inequalities. So some examples for this. Again, we're isolating our variable or our inequality. So we subtract 3 from both sides. That gives us 2 times the absolute value of x is less than 8. Divide both sides by 2. 2's cancel out, and we have the absolute value of x is less than 4. So we know that the absolute value of x is between negative 4 and 4. Right? Remember, this is an and statement. Because it's less than, it is an and statement. So we would graph this as -4 with an open circle, +4 with an open circle, and we are between. Thing that can be helpful to check, right? We know that x can equal 0 works here. So we substitute 0 in for the original equation. So 2 times the absolute value of 0 plus 3 is less than 11. 2 times 0 is 0. So we get 0 plus 3 is less than 11, and 3 is less than 11, which is true. So we know that 0 is inside that solution set. So right here, we've got -10 times the absolute value of x plus 54 is greater than or equal to -21. One thing that I'm going to suggest, don't worry about the greater than or less than sign until we've isolated the absolute value. So we've got -54, -54 gives us -10 times the absolute value of x is greater than or equal to -75. Divide both sides by -10. Dividing by negative, so right away flipping that sign. So we've got absolute value of x is less than or equal to 7.5. So we know that -7.5 is less than or equal to x, less than or equal to +7.5. So we don't want to worry about that. Here we had a greater than, so it would have been an or statement, but understanding that because we divided by a negative, flips that sign. So like I said, don't worry about the sign when you start. Okay. So we can graph this. That's -7.5, and that's 7.5. It's less than or equal to, so it's a closed circle. This is a closed circle. We're between the two. And then again, checking, because we know that x can equal 0. That is a true statement. So we want to check and see, does 0 work? So -10 times the absolute value of 0 plus 54 is greater than or equal to -21. Well, that's 0 plus 54, which is greater than -21. So 54 is greater than -21. That is a true statement. So we know that 0 is inside the solution set. Now we have the absolute value of x plus 5 is less than 1, which is greater than 7. So again, isolating the variable or the absolute value. So you add 1 to both sides. So now we have the absolute value of x plus 5 is greater than 8. So since it's greater than 8, we know that x plus 5 is greater than 8, and that -8 is greater than x plus 5. Right? So this is now an OR statement. So we subtract 5 from both sides. We get -13 is greater than x, or subtract 5 from both sides, and we get x is greater than 3. So here we've got -13, we've got 3, strictly greater than, so we're going to the left. Again, strictly greater than, so we're going to the right. So this is OR statements. Right? Now, here we know that 0, if x equals 0, well, that is not true. So 0's here. We want to make sure that it won't work. So if we put in 0 plus 5 minus 1 is greater than 7, well, that means that 5 minus 1 is greater than 7. So is 4 greater than 7? No. So that's not true. And if you guys remember from proofs, when we did that very little bit of proofs, we have a not true statement. If x is equal to 0, then 4 is greater than 7. Not true statement, so 0 works. And I'll use 0 as much as I can because it just makes it very simple to check. And it gives me a chance to bring in proofs. All right, let me slide this one down a little bit. I'm running out of space when I'm doing them. All right, so now we have the absolute value of 2x minus 1 plus 5 is greater than or equal to 8. Isolate the absolute value, so we subtract 5 from both sides. We get absolute value of 2x minus 1 is greater than or equal to 3. And greater than, so we know that negative 3 is greater than or equal to 2x minus 1, or 2x minus 1 is greater than or equal to positive 3. So remember, this is an OR statement now. Add 1 to both sides, adding 1 to all sides. And that gives us negative 2 is greater than or equal to 2x, and 2x is greater than or equal to 4. Divide all parts by 2. And we get negative 1 is greater than or equal to x, or x is greater than or equal to 2. Okay. So again, graphing this inequality. Here's negative 1, and here's 2. Both are closed circles. So close those up. And we are going away because they are OR statements. Again, we're going to make sure that I'm correct. Luckily, we have 0 you can use. So can x equal 0? Well, no, that is not true. And so when we come up and use 2, or the absolute value of 2 times 0 minus 1 plus 5 greater than or equal to 8, then we get the absolute value of negative 1 plus 5 is greater than or equal to 8, which is 1 plus 5 greater than or equal to 8. 6 greater than or equal to 8 is not true, which is great news because that means our graph is correct. Scan down a little bit again. All right, another example. We've got a lot in this one. Absolute value of x divided by 3 minus 2 plus 12 is less than or equal to 19. Again, subtract 12 to isolate the absolute value. And we get the absolute value of x divided by 3 minus 2 is greater than or equal to 7. And then since it's less than, we know that negative 7 is less than or equal to x divided by 3 minus 2, less than or equal to 7. Add 2 to all parts. Now, this is because of these being the 3-part, remember, it can be helpful. Draw those lines because you should still end up with 3 parts. This is an and inequality. So you add 2 to all 3 parts. So you get negative 5 x divided by 3 less than or equal to 9. And then you multiply by 3 on all parts. and you get negative 15 less than or equal to x less than or equal to 27. So when we graph this, negative 15, 27, both are closed circles. And it's an and statement, so we are in between. And luckily, again, we get to 0. So can x equal 0? Well, that is true. So we need to make sure that 0 divided by 3 minus 2 plus 12 is less than or equal to 19. So that's the absolute value of negative 2 plus 12 less than or equal to 19. So 2 plus 12 less than or equal to 19, and that is 14 is less than or equal to 19. So that's true. So our graph is correct. Last of these examples. So the acceptable radius for a tire must not vary more than 1.4 centimeters from 33 centimeters. Solve or write and solve an absolute value inequality that models the acceptable radius of a tire. So remember, it cannot vary more than 1.4 centimeters from 33 centimeters. So if we have the absolute value of x minus 33 is less than or equal to 1.4. So must not vary more than. What that is saying is less than or equal to, and I use THAN. Okay. The radius I'm just having as x, and so it's less than or equal to 1.4 from 33 centimeters, so that's how I know it's minus 33. So here we know that what that means is that we can have negative 1.4 less than or equal to x minus 33 less than or equal to 1.4. So when we take x and we subtract the 33 centimeters, we can end up with negative 1.4 centimeters or 1.4 centimeters. And so when we add 33 to all parts, then we get 31.6 is less than or equal to x, which is less than or equal to 34.4. So we'd say that the radius can be between 31.6 centimeters and 34.4 centimeters. Okay. Now, there are a lot of practice problems here. Okay. So what I would say is I skipped some of them, and so if you see here where it says example 2, example 2. So if you do D, you don't have to do C. You got 3 choices for example 3. Just do a couple of them, a couple from each. Make sure that you understand these and you're feeling comfortable. Right? Pause the video, and then when you start the video, I'm going to show you the answer key. Right? So here are the answers. C, there's no solution. D is from negative 3 to 3. E is negative 5 or 5. F is negative 6 or 4. G is negative 8 or 12. A, negative 5 to 5. I'm not going to read them, so forth. All right. So that is both lesson 94 and lesson 101. So can you isolate the absolute value inequality? or the absolute value equation? Can you write your solution set using set notation if it's the equations? Or can you write yours using inequality notation if it's inequality? Other than that, complete Concept Check 94 in Google Classroom, complete Homework 94 in the workbook. One more reminder of this, it is 20 questions, your choice. No multiple choice, no true, false, and no student response. So A versus B. Okay. Make sure that you're comfortable with these. If you have any questions, feel free to reach out to either me or Ms. Hughes. Other than that, have a good day, and I'll talk to you later.